Got to give the people what they want. All right, flip it up a little bit. We're gonna do the video like this. I'll kind of start to get people's opinion and what makes it easier for you to see and understand. So today, we're gonna talk a little bit about inverses. So first, you're gonna think about, well, what is an inverse? An inverse is when the input and the output basically switch. The input becomes the output, and the output becomes the input. All right? So you want to go ahead and get that down. So let's take this example. So let's say if I have f of x. Again, you should write this down. F of x equals, I don't know. Actually, unnecessary. Let me go back. Let's say I have f of 3, and that is equal to 10, okay? In this situation, tell me what the input is, and tell me what the output is. Hopefully, you just did that and you recognize, well, this is where x would have been, so my input is 3, and this would be my output. When x is 3, y is 10, okay? So hopefully you were able to get that piece of it. So that means if I'm going to write the inverse, so I don't know if this is what it's actually called, but I'm just going to call it inverse notation. The way that I show that is instead of, if we have f of x is regular function, f of x is a regular function, and f to the negative 1 of x is the inverse function. So this negative 1 is how you show that it is actually an inverse, okay? So let me ask you, for this f of x, right, if I ask the inverse, I would be flipping the input and the output, okay? So I'm going to do a table. Here's my regular function. I get x is 3, f of x is 10. In this situation, I'm going to give you some more values. F of x is 5, 26, and negative 1, 2. So this is from my original equation. What would you think the inverse table from this equation would be? If f of x is this table, fill out what you think this second table is going to be. All right, hopefully you just did that and you thought, okay, well, it says the inverse function is when the inputs and the outputs are basically switched. So this goes 10, 3, I switch my inputs and outputs. 26, 5, I switch my inputs and outputs. And 2, negative 1, I switch my inputs and outputs. All right? So it's kind of simple to see that the inverse is just when your inputs and outputs flip positioning. We'll talk more later about why in the world would we want to do this inverse function, but for right now, we're just going to get the very basics of the inverse function, okay? So now, let's look at this next function, f of x equals 2 to the x. So we're going to make a table of values for f of x, and we're going to make a table of values for the inverse of f of x. So first we got to do the table of values for f of x, okay? I actually want you to do that. So f of x, this first one would be, if x is negative 2, this would basically be 2 to the negative 2 power. I wonder how many people remember how to do that. Well, hopefully you remember that 2 to the negative 2 power is the same thing as 1 over 2 to the second power, which is the same thing as 1/4. So this would be 1/4. 2 to the negative 1 power is 1 over 2 to the first, which is 1/2. 2 to the 0 power. Everything to the 0 power is 1. 2 to the first power is 2. And 2 to the second power is 4. Okay, that shouldn't have thrown you for too much of a loop except for those negative exponents. So hopefully you remembered that. So now that I have that one, I should be able to do my table for my inverse operations. All right, so you go ahead and fill that out. Hopefully you just did it before me, and this becomes 1/4 -2 because the inputs and outputs switch. 1/2 -1, 1 0, 2 1, and 4 2. Okay? And now what we're going to do is we're actually going to graph the original function and the inverse. So I'm going to graph both functions. Sorry, that got kind of smushed in there. So I'm going to graph both functions. So I have -2 and up 1/4, which is about here. I have -1 up 1/2, which is about here. I have 0, 1, which is about here. I have 1, 2, which is about here. And I have 2, 1, 2, 3, 4, which is about right here. So this is my function for f of x. And again, that should look good because it's a exponential. So that makes sense. That's how an exponential function looks. Now I'm going to graph the inverse. So now, when x is 1/4, y is -2. So that's here. When x is 1/2, y is -1, about here. When x is 1, y is 0, about right here. When x is 2, y is 1, about right here. When x is 4, 1, 2, 3, 4, y is 2. So this one, the inverse, looks like this. Now what do we notice about the graph? Excuse me, this is f to the -1 of x. Well, you should notice some type of symmetry. And it's actually, you should notice, like if I fold kind of along the diagonal, like I want to say that is, it's like a mirror type symmetry along this diagonal. If I folded over, up, or down along that diagonal, they would match up. So these inverses have that type of symmetry, okay? So this is kind of the beginnings of inverses. Basically flipping the x's and the y's, you'll see that they have symmetry. You see the different type of notation that you work with. That's about the extent of what we need today. So I'll be looking for people to come back with this information in your notes, and we'll use it for class tomorrow. All right, have a great day. Thanks.